Wow. Dylan, you're already here.
Yes, sir. I just joined right now.
Okay, thanks a lot. It's already a recording, which is okay.
Hello, everyone. Hi,
Hello, how are you?
I'm good, thank you. How are you doing?
Ah, thank you. Sorry, I saw your information to change when I had already posted. I saw
No
it
problem.
now.
No
Yes, you are
problem. It
well.
was just a fun joke. Thank you,
Otherwise,
everyone.
yeah. How are you on your side?
All well. Pretty busy with work. I'm auditing option language, so it's
Yes.
being busy and tiring. Yeah.
Oh, that is nice. That is okay. Fantastic.
Hi, Dylan.
How are you?
I'm good, thank you. How are you doing?
I'm alright. I'm alright. I'm doing well today.
We are going to just maybe give a little bit, wait a little bit, 5 minutes. I was so busy all 2 weeks, so busy that I only wake up to say, oh, I'm supposed to do this. Then I start running up and down, even if I'm scheduling sometimes. Yo, it is a lot of things happening. All right. All right. Let me, I think others are also sending messages. Okay. Let me send them the link. And they're going to use this one. See. Uh, yes, let's see this one. Morning. I think I have seen Daniela this afternoon. You're welcome, Daniela.
Yeah, I think she's here.
Yeah.
A quick question to Dylan. I remember you are part of Coaxygen classes, right? You take classes from them.
Yes. I was there last. Was it 2 weeks back? If I'm not mistaken.
Oh, okay. So
Yes.
you are also trying to learn other languages, like Aiken or Plutarch.
Sorry, can you come again? I don't know if it's
So are
my.
you also thinking about learning other on-chain programming languages?
Yes.
Aiken.
Currently I'm actually learning Bluetooth.
Okay, okay,
Yes.
nice.
Yes. I did gain some knowledge from Helios. Yes,
Oh,
that's the first one that I started, and I believe that Mr. Spanda did develop Coxlib, which helped in understanding because it's not easy to say. Yeah, it's not really the normal. I was in aware of Web3 at all, so it was my first time actually doing it. But now I,
oh,
I, I
okay.
do have some knowledge, the on-chain code, off-chain, um, some of the functionalities. Yes.
I see. Good. That's good to know. I save you.
Oh,
Good
Xavier.
evening, sir.
Xavier, we meet again.
Yes,
Thank you.
sir. Good evening, sir. Good evening, sir. Thank you, sir.
Yes, Xavier. Yeah. This is being recorded, so we can always share it with any who will join later. Remind me, Sukanya, about these trainings that we are having, that I get access to the recordings, we put it online and show others that attend later.
Sure. Yeah.
Like
We
the one
can.
you did last week, and the other one that I did. Those recordings, how do we access them so that we share them with the others?
Right now it's in the Google Drive of Intersect. So I
Oh,
think
yes,
it's better we check with Terence, and then yeah, we could think about how to share them.
how to share them.
I think they'll have access issues for now, but we will check with Terence. It would be
All right,
great. That idea is great. Yeah.
awesome. Okay, I think we can start. I would like to welcome everyone. Thank you, Sukanya, for being here. Thank you, everyone, Daniela, Dilon, Xavier, and Trefina. This session today, it is going to be based on package managers, which are highly used in Cardano. Those are Stack and then Nix, and the other one is Kapal. Most of us here might, if you are very new, like I think Victor, package managers, I can give you an example like on the JavaScript side, NPM, NPX. These are tools that are used to download libraries from package repositories. They make life easy. They manage dependencies on your projects. You are going to see, as we are working on Haskell and all other tools we are using, we are going to be dealing with these package managers. So let me give an overview first on these three package managers. All right, I think you can see my screen.
Yes, we can.
Basically, what I'm going to present
Yes.
is a Stack, then Kapal, then Nix. Then we look at how are they different. And then from there, we are going to have a table of comparison. Then we are going to see them practically. How do you use them at a basic level? Before I go through this presentation, we've got different developers. Some like Stack, they use Stack because they were using it in the past, and so they are used to it. Some they like Kapal because they've worked with it on different projects, but a lot of developers, you are going to always come across projects that are using any of these three, or there are other package managers again, which are useful. Right, number one, introduction. Haskell has several powerful built-in tools for managing dependencies, building packets, and creating reproducible environments. This presentation covers three of the most popular tools: Stack, Cabal, and Mix. Number two, Stack. Stack is a Haskell built-in tool focused on reproducibility and easy of use. Common commands you are going to come across on Stack the following: build. It is having Stack as a command, and then the next action, what it must do, the command build. Then Stack run, Stack test. Right, we can have Stack exec GSI. This will run the compiler in an interactive mode. The advantages of Stack are reproducible builds via curated stackage snapshots, easy setup for beginners, built-in project scaffolding, isolated build environments. The disadvantage is a large initial download, less flexible for advanced customization, not ideal for contributing to GHC or using bleeding edge packages. Right, the next one, which I'm going to go through, is Cabal. I've seen some, they pronounce it as Cabal, but I will save Cabal for now. It is the official built-in system and packaging tool for Haskell. It has the following commands: Cabal update, Cabal init, Cabal build, Cabal run, Cabal test, Cabal repeat. We're going to see from Stack to this one here, we have got update on Cabal. It is not there on Stack. There is here on Stack, also Stack init is there. When we run Stack init, it's going to create a YAML configuration file. Here it will create a Cabal configuration file. Right, this is for building and compiling. It will produce the EX, the executable binary, and the object file. And then here it is for running EX executable that are built here. So the order is also very important, especially build comes before run. But with the test, you can run your test, they're on a separate file, then you do your run your main. Then the repeal on the Cabal side is for launching the GHCI in a interactive way. Advantages of Cabal: fine-grained control over builds, better integration with GHC and Hackage, supports multiple projects components. And then disadvantages: dependency hell. Yeah. Before version 3.x with sandboxes. So this has been solved a little bit after version 3 going forward. Cabal can be harder to get reproducible builds without mix or freeze files. Then the third one, which is I'm going to talk about, is Nix. Nix is a purely functional package manager that can be used to manage Haskell and system-wide environments. Let me also tell you about Nix. When you hear the word Nix, don't immediately associate it with package manager, because there are three parts of Nix. One, it is an operating system, like Linux, like Windows. There is Nix OS. Number two, Nix is a programming language, like Haskell. It is a functional programming language. So when you hear Nix, always try to check the context in which they are talking about. There is Nix package manager for managing dependencies. There is Nix OS, an operating system, and then there is Nix, a programming language. Right. And then the common commands here as a package manager, you are going to use or come across. And then it's Nix shell, and then Nix build, then Nix develop, Nix flag init. When I'm going to go through practicals here, I prepared 3 different projects, which we are going to run through practically, so that you see this in practice with a demo Haskell application. What are the advantages of Nix? I think it is obvious. If it is a programming language, number one, it is a powerful thing. It is a functional programming language. If it is a package manager, then you know those libraries are functional programming language packages. So you see that advantage again. If it is an OS, that type of an operating system. But in this case, the advantage I'm giving you, which we see here, is comparing it to package managers. Number one, it is a full system reproducibility. It has full system reproducibility. So you've got, we always have a problem as developers, very common problem. They normally say it works on my machine. What they mean is I create a project and I test it, it's working. Then I share it with others on GitHub. Then on their machine, it's not working because they are using different operating systems. Even if they are using the same system, you are using, let's say it's Ubuntu, but you might find they have different versions they are using. Even if we have got the same version of Ubuntu, same version of Ubuntu on the other side, then we've got other issues again that affect reproducing your dev environment on different machines. So let me give you a good example where Nix is used a lot. When I'm cloning PCs that have got almost the same environment, it is better you use the Nix, because then the moment you set it up on Nix on one platform, it has got a file. Basically, it follows it is declarative. It follows that file and downloads everything according to a declarative configuration file, making it possible now to be shared across. That is why it's written full dash system reproducibility. Second advantage is cross-platform. Now, that environment with that file, the moment it is working, it has the dependencies, and you're working with it, can then share it with different platforms without a problem. And then also it integrates very well with the continuous integration and DevOps workflows. Right. Already, I think you might immediately say, therefore Nix is a winner. Nix is a go-to package manager. I will say, wait a minute. The disadvantages of Nix it has a steep learning curve. You will also need to learn the language, which is functional programming language. So that part is disadvantage. Right, it has got very complex errors and messages that can take you quite some time to resolve. And then the other disadvantage, it requires you to understand its syntax, because remember, it is a programming language. So you need to know its syntax. Let's compare now. Right, I'm going to compare using reproducibility, beginner-friendly, system integration, flexibility, and learning curve. But one thing I would say is all of them are very important. They have been used in various big projects for the past. So if you are asked to work on a project that has got any of these, can't say, no, I can't because I only want needs like this. No, you really know if they have been using it and they're used to it, there is good reason there is legacy code. Number one, stack. Let's look at reproducibility. I think all of you are with me here quickly. Yes on reproducibility, stackage, and cabal, partial with freeze, and next, yes, full system reproducibility. Friendly, beginner friendly, yes, stack, and then cabal, no, mix, no. System integration, stack, no. Cabal, partial, mix, yes. Flexibility, stack, partial, flexibility. Cabal, it is flexible. Mix, it is flexible. But when it comes to learning curve, this is when a stack shines. It has a lower learning curve. And then cabal, medium, and then mix, it has got high. So you can see at the end of the day, this one is good. This one is a problem. Here it is good. This one again, you see, it's not friendly. Learning curve, see this one, an advantage here. My suggestion to all beginners, also those who are doing Haskell at universities, is you need to learn all the three. And I always encourage you also try to create your own package manager, because it was developed by other developers who saw a need for it, so they engineered it following certain problems and solved it. So learning all of them, how they are created, how they work, how to troubleshoot the problems they come across, is very important. So this is not the end. This is the end of the presentation. Then we are going to do some practicals. Right, use Stack for quick starts and processable apps. Use Cabal for fine-tuned Haskell builds and ecosystem native workflows. Use Nix for fully reproducible environments, especially in polyglot teams, DevOps setup. But like I said, each tool has its place, and depending on your goals, team, and the complexity, all of them are very important. Right. Keep your questions if you've got questions. What I'm going to do now, I'm going to run through some practicals so that we all have hands-on on these tools. Right, I've got one project which has got 3 different projects inside. We have got the Cabal. I normally see it clearly when we go via the command line, but I think everyone is used to the VS Code Explorer, and you can see that. So I've got basically a project here, MSSD. Just to explain a little bit about this project, I created 3 modules. screen right now. Let's change this MSSD is a mock. You know a mock. It's a demo. A mock of the decentralized exchange. So MSSD. So basically, this we have got like an exchange where you can swap your tokens in a decentralized way using atomic swap without a meeting map. So basically, the remote modem is set up. We have got the exchange itself here, and then basically this is a very simple token and an instance here, and then list the token, view the
Pranav,
list.
sorry to interrupt. Are you
Yeah.
sharing some other screen?
Oh, sorry. I think I was
Ah.
sharing the tab. So when I switched, it was no longer sharing a window. Let me share the entire screen. If there is a need for me to switch, then I don't lose you. Right, sorry for that. So you can see my screen. Is it clear now?
Yeah.
Okay. So let me start very quickly. I was explaining the project basically to say on the source directory here, we've got these modules. I've got the exchange module with the following exported functions in the class. And then I've got an LP token, which has got the function generate MLT tokens. And then the token that is going to be traded on the exchange. Then I've got a module user, very basic. And the most important thing we need here is we need to use the main to import them. And then from there, we just run simple test. And the token, we print the user, we print listing, and we print that. So we just generate dummy data for Sunday swap with 1,000, 10,000, and then we've got the paid user, Alice. Then the listing, it is listed this token, Sunday swap, they are listed for 2.5 ADA. And then LP token generate for Alice and Bob. Put those two there. So don't worry about the functionality for now. All what we want is here is a project, and then if we go to this one is a Cabal project. You can see there is a .cabal configuration file. So we see here it is using version 3. This is the name of the project. And then here is the Haskell source directory, which is SRC, which is this one here, exposed modules. So here you need to specify on your library which modules are you exposing, which are going to be imported by other files. In this case, it is a token, user, LP, and exchange. Right, this depends on the base greater equal to 4.7 and less than 5. So some of these, if this is not met, it will throw an error. And the executable part, MSSD-EXE. Also, where do you find the executable part? It is on the app. That is where we have got the main file. So we've got this directory app. There is this main file. I think I tried on the README to show a little bit some of this basic structure here that you see here. Right, let us say you download it, you clone it onto your machine. I skip the cloning part. You know you need Git to run your Git, and then you get the URL from GitHub. Clone it on your machine, then from your machine, you open your VS Code. We are here now. Right, remember this Kapal's techniques is a bigger directory, so inside it, we have got the various ones that we need. So you need to, I always make the same mistakes of trying to run commands in the wrong directory. Then you might say, but it was working, now it's not working. So you move to MSD and then Kapal final. So I'm here now on this one here. So this one, you think from the command line, you can see where we are. Then you will see immediately on the Kapal side, there is a .kapal file there. Then you can start your Kapal update. Sometimes it can take time if it is a big project. This one is a smaller project. It won't take a lot of time. And then what does the update? It changes the index. And then like in this case, you see the index date is set to this part. You can run Kapal clean. What will Kapal clean do? I'm not going to run it. It is going to delete this file. This folder here has got compiled ex some other files inside. So I'll skip Kapal clean, then I'll go to Kapal build. Also Kapal build can take quite some time. So if you want to run Kapal build very quickly on your machine, there is one thing I didn't explain to you, because from these three, these are very simple demo. We are going to go to the actual Bluetooth project. That one is the actual enterprise project that we are going to be working with most of the time. So when you are building that one, yes, it is a lot of, it's very big, sometimes, I don't know, gigabytes. So when you run Kapal build, first time you run it, it will take quite some time downloading. So I forgot one most important thing. What are the prerequisites when you are developing, setting up using this? For the Cardano projects, it is very important that you have got a multi-core processor. How many CPUs? I've tested especially the Bluetooth with my machine here. The reason is so that we can estimate the time it takes. Here I've got 12 CPUs. So you check on your side how many CPUs you have. Why is it important? Because now when you are running Kapal build, it can take a long time. You might even cut it by mistake. Your internet can disconnect when it is in the process. And you can even take a week and get frustrated. I want to suggest from advance to say, all right, make sure you've got a multi-CPU, what I have. And the memory, I think 16 gig. 16 gig. 32 gig is okay. But if it is not affordable, 16 gig, 4 gig, I would say no, not for the Bluetooth. This is where here, when I'm building and I want it to build fast, it is where I will tell it, to use all the CPUs. That is why now it will run very fast. You see, up to date, because I did that. When I was using 12 CPUs, it took about 8 to 9 gig of RAM, but still it took around 7, 8 minutes. And also remember, it's downloading information from the internet. I tested also the bandwidth. If your bandwidth, internet bandwidth, is very low, less than 5 megabytes, it's going to take longer to download. You might even leave it and go and have a cup of tea, come back, and you still find it downloading Bluetooth. So my recommendation for your internet bandwidth is 10 megabytes and above. 15, 20 megabytes upload and download. I think it will do the setup very quickly for your Bluetooth. But a lot of people are frustrated that they can't get started with these plans or Bluetooth. Here is my advice. Give yourself time to set it up. Once you have set it up, then it's okay. And if you have got the right machines and the specs that I have given you, you mustn't experience a lot of problems unless you have got now the dependency problems that will arise as you are installing. Okay, so now once you have built, what does it do? It creates the EX file. Where do you find the EX file? On this one here. It is where I'm showing you. There it is. This EX file. Then from here now, I can run that EX file. Use Kapal, run dash EX. Why? Where did I get this MSSD? If you go to the Kapal, where are we here? Here, this is a configuration file. Our executable is that. That is why I typed it here. And then it is going to go to the app. This is for the source, where the main is. And then it will go to the executable built here and run that one. And then it is working now. You see, where is this coming from? This is the main. If you open the main here, we had to create this Sunday 1000. There it is. Then we are testing using this 4 lines. That is what we have here. Basically, those are the steps that we have for this basic. There is, on this example, I'm going to upload it and give it to you. There is a README file with these examples that go through. So if you have got any questions for now, let me go through Stack. Stack, what is different here? The projects are the same. So I won't explain the projects, but the configuration file. Stack has got stack.yaml. This one, I open this file. It shows the resolver key, LTS 2217 packages, extra dependencies, null, nix, enable false. So this is very important, so that if there is a nix on the way, it avoids it. There is also a .yaml package. I don't know why there is that exclamation behind each configuration file. When you run a stack init, it creates it like that. But this is different from Kapal and also similar to Kapal. If you compare this to Kapal, you are going to see this first part, the project name description version, and a little bit dependency. And then we've got dependencies, libraries, and also source directories. And then also it has got this section for executables. So I named it so that you can be familiar with it. There is the main, there is the app. And then here with this one here on stack, I added a test directory and with the test so that I show you test command. So I'm going to switch back and then go to stack now, which is the SSD. Right, stack final. Right, you can see on this one here. Now you might ask me, but why are we having a MSSD cabal file on the stack when we have a package.yaml and the stack.yaml? I've not been using this a lot, but I realized when I was running it and this was not there, it wanted it to be there. Then I had to copy the other one that was there. Then I brought it here. And then it's almost similar, but a little bit of some differences. You can compare it there. Right, what stack does, it will pull down all the dependencies that you have defined on your package here. And onto your install GHC, and also once it is done, then from here you can run your cabal commands. So here is the README for stack, and basically the commands for running it for me, they were very short. The first one was stack build, then stack run. I've already run stack build, and it did build the app. So now I can run stack run. If there is nothing built, it won't run. So let me run it there. Right. See this notify dash if configuration if there is an error. It's a warning, it's not an error. Right, let me check if you have a file. It is similar when I get on to the next, but there will be a little bit of some differences. Let's just finish with this one here. Number 1 out of 3 is compiling the main.hs. And then number 2 out of 3, it is a little bit. What did I want to show you there? 2 out of 3 compiling stack setup shim. You can see the path. 3 out of 3 it is linking. You can see the what you call URL there. Right. So for this one, I'm going to cut it. You allow it to run. Let me run a stack run test or stack test. In this case, I'm going to run this part here, the specs. What is the specs having? It is a test file. It is going to test the token, also test user, test exchange, LP. Right. Let's check it. Right. Meanwhile, it is processing that side. It is finishing. Press 1 out of 8. Quick check. Two out of 8. All right. As it is running, let me be using this to explain the Nix part. I'll only explain the configuration part, which is the one that is a little bit different. Let's hope it will run and finish without an error. Let's see, 4 out of 8. On the other projects there, I didn't add a test folder and a test file. I only ran the main. But on this one here, for the stack, this is what I have. Right, it has finished. It is pointing at some errors here, like it couldn't find the user, importing this and this. Let's see here, process code takes this one here. Right, maybe what I need to do is to run stack build. All right, the same commands build, run are similar because it might build and take a long time. Let me skip that. Let me go to the next one. On the next package manager, you will see there is a file called flag.next. And then if you look at this file, it is an object file, but inside it, it has got a way of declaratively presenting your needs, the dependencies. I'm not going to explain the next language, this part. This is what you can go and do, learn the next language, so that you'll understand how this input in let in this package in here, it works, and then how it is used here. But the most important part about this, it will download the dependencies onto your machine, and then it will also create a log file, this one here. And then from there, it also has got a Cabal configuration file. And then from this one here, I can just test it for you. Let's go back to this one. Right, the commands the way I listed them for you. The first command you run, there are so many different commands for Nix. For now, when you get a project like this, inspect this one. And then you also go to the README. The README will take you through which command you need to run. Right, let me come here. If you want to enter the Nix shell, you use Nix dash shell. And then you use Cabal build, then Cabal run MSSD. Let's try that. So here, Cabal update. And then from Cabal update, we run Cabal build. And then from Cabal build, then it also going to have this file here, this folder. And then you will have all your builds here on the next side. All right. On the Cabal update part, it is finished. Now let us run Cabal build and then J. You can specify the number. You can say 2. It will use 2 CPUs. You can say 4. instead of using all available processors. All right. Meanwhile, going like this, I think this is good enough for you to go and read and then start practicing with what I have shown you here. Right, so it has used all the processors to build this very quickly. And again, this is a demo, small project. So from here now, let us run Cabal, run nesd ex. Okay, there, it successfully ran. And then there is the main from the app, this one here. Right, in short, so that let's have a Q&A. What have I done? I have shown you how to set up and install and run the Nix Kapal and the steps. Thank you so much. Let's have some questions.
Yeah, I do have a question regarding the Cabal build. So each time you make changes to your project, you need to go all through that process, Cabal build, and to run the actual project itself. Like if you make changes on the project or on your...
Yeah. Remember, what does the build command do? It compiles that main and produces an object file, and then it also produces a binary file. So when you call run, it is going to run on a binary file that is updated. If you don't run build again after making some changes, and then when you go to run, it will run the previous build where the main didn't, or the changes were not there. If you want to just quickly test, prototype your functions, then use Cabal repel.
Or the one on the CLI, on the command line.
On the Cabal repel. Right. And then from the Cabal repel, then you can load your modules, then you can test them. Load main, and then you can test it. So if I say repel, right, if you see now, the more it has loaded that interactive mode. Here you don't need to build. Then from here, I can interact with this token. So I can basically create a token with a name and an integer. And then from there, test it. Right, we can test it and say let en for token. And from here, I'm going to say Bernard, this token 5. Could not match to token. All right. Okay. I see where I made a mistake. Right, I need to specify token here. All right. And then I can type now TN. Yes. You see. Okay, it is Bernard quantity 5. I've made changes. I'm testing my function for each module, which is token here. Right. So I can also call the function. Let me test that function here. Create token. Let's go token. Then I need to give it a name. Let's call it DA for developer token. Let's say this one is 8. Right. You can see it has called this function with a string DA and 8 of them. And then from there, it has created a token and it has given us back a token. So the code is working without an error. So let's suppose there was a type error there. So when we run that, right, I need to reload. At the moment it is using a changed. This is another thing you need to see. Error for reload. Okay, and then now, let me run it. I was hoping it was going to throw an error. Okay, that is an error, but it is running on the other side. Okay.
Doesn't it need to be built again?
Oh, I didn't save. The reason why, remember, I'm trying to show you when to use build.
Okay.
When not to use build. For example, if you are testing your module for errors, let me save that. I hadn't saved that. So I want to show you if you are debugging at the same time building up your modules, and then you want to test them. I don't know where I'm making an error there, but it is working. But this is what you use. You can use this. Then you can also build it into, you run build again, same way I did there, and then you can test your main. So this is going to be tested without at the moment. I don't know if this does help you. There are some other interactive prompt commands you can use here. Want to load another module, say L, let's load user. Sorry. It says not in scope. Right, it is not in scope. All right, let me give you the other commands. Then you are going to experiment with them. So it means here, you've got M for module, R for reload, L for load, set, go and practice them. And Q for quit. See, this is where we are. All right, I see now we are over time, but play around with it. Any question? Any other question? All right. How did you find today? Was it too confusing? Did it help you see a little bit how these different package managers are used?
Yeah, it did show us a different side of how the package managers are used. I only knew of Cabal. I once experimented trying to create a Haskell file to build. Yeah, so I didn't know that there are more of them.
All right. Thank you so much. I'm going to upload this and share the GitHub to that project. I wanted to show you the Bluetooth before we go. Sorry, I know maybe some of you want to jump onto some other meetings. Because I was just using a demo there. But what about now? I really want to work with Bluetooth, which is where we are. All right, let me load a Bluetooth application here. Right, I've got a Bluetooth NICs, and I've got I can load this one so that you see it. Also, there is one for Kapal, Bluetooth for Kapal. There's one also for NICs. Let me start with the one for NICs. I'm not going to build it. It takes quite some time. But what I want you to see is the similarity in the folder structure. Now, when you are setting up Bluetooth, you can use this Docker. I'm not going to use Docker for now. So I just want to show you here. It's similar. You see that this dash new style. This is where there is a compile. If we go to build, and then in this case, what is my workspace? It is WU space. This is where the files are. Then on the build side, there you go to the X, and then you go to the build. There it is. This is a vesting application, right? And then when you run and build that vesting application, then you say kappa run. The files here in this case are here on the W space. Right, on the W space for workspace, you have got this folder asset. This is where I'm storing my .bluetooth file. Like that one, I'll delete and then run it. We should be able to build that vesting, which is this one here. And then there is also a test, and say kapal run test. Right, you can test the commands. But what I want to show you here is this. Now, this is going to be familiar with you following my explanation. And then also there is another kapal.project. It's a lot of some settings. Then there's also kapal.project.local. Okay, and then right, with this one here, I think especially the beginners, you need to be very careful where you are to test the Bluetooth. So you need to move, in this case, to code. And then in the code, you can move to the workspace. And this is the workspace. See, there is a YAML, there is a workspace.kappa. And then this is what I want you to see where the next file is. It is not inside here, the workspace. The next file is at the root here. Then I've shown you let me look at this next file versus the one that I showed you there. But this one is real now. It shows you even the dependencies that you need. This cryptographic package, libsodium, declaration, the zlib, the kel here. And then also this one specifies the GHCI dependency, also the kapal dependency. Let me check GHC version. Right, you see that one it will run. Then we check the kapal. Right, the version you see 3.10.3. One is point that one. I don't know what issue it can cause. Let's run Kapal run, and then we let it run this main file, which is on the W space, which is specified on the local Kapal. So on our executable on the local Kapal, it is that Kapal run investing ext. It is going to produce a file here .bluetooth, and then that .bluetooth is the one that we are going to use on our Helios off-chain part to build up a transaction to send to the on-chain. But there, it has done that. You see, there is, it has produced that. So everything's on. Also, here again, remember you can turn it onto the interactive part using Rappel, Kappa Rappel. So now, similar, if I switch to the stack, you are going to see it has got the .yaml configuration file, and also you use those web. I've managed to build using stack. I've managed to build this using Nix. This one is a Bluetooth Nix. And I've also managed to build the Bluetooth, which we are using for our Bluetooth compilation, using Stack, Kapal, and Nix. I think I'm going to stop here. I will also upload this. And the nice thing, I started with a folder structure of 80.kb. Then I built the vesting. Then I checked after building when it brought in all the dependencies onto the folder. Then I checked the file size. It was, I think, 1.5 gig. So what I'm going to do, I'm just going to give you, I will delete this part here, because this part is the one that is very big, because it has got the build and the also cached. So I'll delete it, then give you back as 80.kb, kilobyte, less than 1 megabyte. And then you go through setting it on your machine. Then you can help give me feedback to tell me what machine you are using, what is the CPU, what is the RAM, how many CPUs. And then we see if you are going to succeed on Windows, also on Windows with the Linux WSL, on Mac, if you've got Mac. I have used here the Ubuntu. If you're using Ubuntu, tell me your version, 18 or version 22. Thank you very much. I've gone over time by 11 minutes because we started at 10 past. Yeah.
Thank you.
Thank you so much.
Thank you
Suganya,
so
over
much.
to you. If you've got your last words.
Oh yeah, thank you so much, Bernard. It was very useful. I hope
Thank you.
everyone was taking useful notes. Thank you, everyone. See you in 2 weeks.
Thank
And
you.
also, if you have been working on any project and if you have any pain points that you are not able to get past, you can reach out to us, and we can also discuss that as part of the working group.
Okay.
Awesome.
All right. Thank you.
Thank you
Thank you
very
so
much.
much.
Try by all means to get these videos so that we can share them with others.
Sure.
So,
Yeah.
yeah. I will upload all the source code onto where anyone else who goes through the video can get their hands on, because one of the pain point people have complained about is setting up the environment. And they've even developed what we call a phobia for the Cardano setup environment. have a phobia for needs, whatever. I will tell you from my experience where that experience, the bad experience is coming from. Number one, the hardware. If you have got a hardware, like I tell you, 4 gigabyte RAM, and if you have got a bandwidth, the bandwidth, let's say less than 10 megabytes per second, and also if you have got maybe a PC that doesn't have a lot of CPUs. Sometimes you can have 10 CPUs, but you don't use them when you are building the process. It will take very long. Sometimes along the way, there will be dependence issues. Then they will force you to rebuild. Imagine 5 gig and along 2 gig there, and you took the whole day. And then there's a dependency issue that is emanating from your operating system. Then it breaks everything. Then when you rebuild again, it hasn't cached everything. That again, that is why on the IOG, you need to set those binary caches. And if possibly, download straight the binaries that have been compiled by IOG. Because people don't like getting a binary and then you run it on your machine. There's that trust issue. Get my point? So they prefer using their own source code, inspect the source code, that is nothing malicious with the source code, then build it themselves, which is very safe, and then use that binary on their machine. So we are going to be there for all the developers to just assist live on this as Intersect developer advocates. Thank you so much. Help us get the video online so that we can share it across. Thank you.
Sure.
Thank
Thank you, everyone. Take care.
I really
Bye-bye.
appreciate those of you who came.
Thank you.
Thank you.
Thank you so much. Awesome. All right, Sukanya, thank you so much.
Yeah,
we
thank
will
you. Mm.
connect maybe in the chat.